Hello Year 8. In this video I'm going to give you an overview of systems and control in relation to the Nightlight project, which is your new project. So your objectives today are to understand what we mean by a system and what inputs, outputs and processes mean. Just to recap, the other day you should have done this lesson and written a design brief relating to these images. So you should have thought about issues that parents of toddlers and young children experience. And your design brief would have been something like this: to design and make a nightlight that will appeal to young children. This will make it easier for children to sleep, so it gives parents more of a rest. And that nightlight is an example of a system, and you would be making one in school. What you do is you put it in the dark and it comes on. So your first task is just a thinking task. I want you to look at the pictures and pause the video. What do these products have in common, and which is the odd one out? Pause. Well, the answer, if you hadn't guessed, is the hammer. Apart from the hammer, each of these products is an example of a system, a device where the input motion or energy is different to the output. So if you swing a hammer in one direction, the output motion of the hammerhead is the same. In contrast, this monkey toy, for example, you wind it up with some potential energy, and then when you let it go, it claps its hands and it moves. So the input rotation is different to the output motion. That's a simple system. So are all the other systems. Right, a simple copying task more or less. Define the characteristics of a system. Well, there's your definition. A system contains parts that work together to produce a controlled task or activity. This consists of inputs, processes and outputs. Within the system there can be many subtasks or subsystems. So pause and copy. Task 3, I also want you to sketch a hairdryer and break this system down into its basic parts in diagram form. So can you sketch a hairdryer and then just in box form tell me what you think the input, process and output would be? You can pause, I'll give you the answers in a second. Right, the answers, so input, you plug it in and turn it on. The input is electrical energy. The process for a hairdryer is that the electricity powers the fan and a heating element. So the process, electrical energy, is converted into heat and movement. The output, well, it's just hot air flowing. So it's a simple copy task. Here's an example. It might look something like this. Okay, task 3. Just think about this. What does manual, automatic and semi-automatic mean? You might think of weapons, but we're not doing weapons. That wouldn't be appropriate. Here's 3 examples. You've got a hairdryer, a bicycle, and a central heating system for a house. Again, it is a copy task for now. A manual system, write this down. The user tells the system what to do and makes most of the decisions. An example is semi-automatic is triggered by a user, but the main functions are performed automatically. An example is an automatic system. Once it is started, operation continues without involvement of the user. An example is. Okay, just want you to think. You can pause now, copy them down, and then think which of those examples is which type of system. Okay, and when you've done, let's check it. The answers are actually like that. So for example, a central heating system for a house is automatic because once you set the temperature, it will regulate itself and turn itself on and off at different times of the day. Okay, your next task, you're going to draw this table with a little sketch of a kettle, a fridge and a handrail. And I want you to say what type of systems are these and why. So copy that out, pause the video. So what type of system is that? And then give your reasons at the bottom. And that's the same for each 3. Pause now. You should have done now. And the answers, if you're interested, are all semi-automatic, automatic and manual. Why? Well, with the kettle, the user activates the system, but it has a temperature sensor to turn it off. So that is the main function of that. The heating of the water happens automatically. It just needs to be turned on. And then it turns off itself. Now, a fridge is automatic. Now, the reason for that is once it's operational, the fridge automatically adjusts the temperature with no user interaction. So you turn it on, it knows that if it gets too hot it cools down, if it gets too cold it lets it warm up. It's thinking for itself. And then finally the hand drill, the difference here, the user provides all of the input, which means the user has to turn that handle around and around, and if the user doesn't do it, nothing happens. Okay, so your final task, this is an extension. Okay, if you've not completed all the work in the hour, I want you to look around your house and find 3 examples of systems. Say if they are manual, semi-automatic or fully automatic, and explain what the inputs and outputs are. There's an example for you. Alright, good luck.